Good morning, good evening, good afternoon, everyone. I'm Mrs. Williams, and welcome back to my channel. This will be the start of a three-part series on the representations of data sets. But before we get into that, like always, I'm going to give you the standard and the essential questions for you to write down in your composition notebook. Today's standard is MGSE 9-12.S.ID.1. I can read, interpret, and create graphs to represent data sets. The essential questions are: number 1, why should you use graphs to represent data sets? Number 2, how do you create a box plot? Number 3, which statistics are easily calculated from a box plot? And number 4, what are some advantages and disadvantages for representing a data set using a box plot? So we've been talking a lot about data sets or lists of numbers, but is there a better way that we can represent that list of numbers? Sometimes it can be very tedious to look through an extremely long list of numbers. So we need a better way to represent that list. That's where graphs will come in. Specifically, we're going to talk about 3 different types of graphs: box plots, dot plots, and histograms. So this will be a 3-part series. This video, we're going to talk about box plots. Box plots in particular lets us easily calculate or easily find out the minimum, the maximum, and the quartiles of a data set. And I'm going to put a picture of a box plot like right here, because chances are you've already seen them before in previous grades, but we're going to talk a little bit more in depth about them. To create a box plot, you need 5 numbers from your data set, and that's the minimum, the maximum, Q1, Q2, and Q3. And we call these 5 things the 5-number summary. If you can calculate these things, then creating a box plot is very simple. So let's go ahead and work an example so that you'll understand better. So let's look at the following example. We're going to represent the following data set as a box plot. So this is a pretty long list of numbers, and we want a better way to represent it. So we're going to do that using a box plot. And the first step says that we have to calculate the 5-number summary, which is the minimum, the maximum, Q1, Q2, and Q3. So to do that, I have to put my numbers in order from least to greatest, which would be 3, 4, 4, 4, 7, 10, 11, 12, 14, 16, 17, 18. So making sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 numbers. My minimum is always the smallest number in the data set. So 3 would be the minimum. The maximum is the largest number. So that'll be 18. So now we have to find Q1, Q2, and Q3. So to find Q2, I will simply have to get the 2 numbers that are in the middle, which is 10 and 11. And I will add these up and divide by 2. So if you add 10 plus 11, you get 21. 21 divided by 2 is 10.5. So that's Q2, or the median. So every number below this would be the lower half. Every number above this would be the upper half. So upper half, including 18, and lower half. So looking at my upper half, I have 1, 2, 3, 4, 5, 6 numbers. So that means I'm going to still end up with 2 in the middle, in which this case is there. So I would add these two together and divide by 2. 14 plus 16 is 30. 30 divided by 2 is 15. So Q3 would be 15. Now we'll do the same thing with the lower half. I will find the two numbers in the middle, which is 4 and 4. 4 plus 4 is 8. 8 divided by 2 is 4. So that would be Q1. And there's my 5-number summary. The minimum is 3. Q1 is 4. Q2 is 10.5. Q3 is 15. And the maximum is 18. So that's my first step. Alright, the second step says to draw my number line. And I need to make sure that my number line is large enough to include the numbers all the way from 3 to 18. So I'm going to use my ruler and draw my number line. So just to keep it small, I'm going to go by 2s. So 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So therefore, I've drawn my number line and it's big enough to include all of the numbers here. Now the third step says that we have to mark the values in the 5-number summary with vertical dashes. So for every number up here, we're going to mark it on our number line. So let's mark 3. Well, 3 would be between 2 and 4. And I'm just going to draw a vertical small line where 3 would be. My Q1 is 4. So I'm going to draw a vertical line right above 4. Q2 is 10.5. So that means it's going to be between 10 and 12. But a little closer to the 10. So I'm going to put about right here. Q3 is 15, which would be between 14 and 16. And then my last one is 18, so I'm going to draw my vertical line right above there. So that's the third step. Now we have to draw the box part of our box plot. And we simply do that by connecting the line for Q1 to Q3 to draw a rectangle. So and there's the box. Now we just have to connect the ends by drawing horizontal lines. And that will be our box plot. So let's take a look at our box plot. This box plot represents the same data set up here, but we don't have the individual numbers anymore. All we have is this. But it gives us a lot of information about the data set even though we don't have the numbers. So when you look at a box plot, remember that this line is always the minimum. This is always Q1, Q2, and Q3. And this one's the max. So even though we don't have the original numbers anymore, we still have a lot of information from the box plot. For instance, we can calculate the range. Even though we don't have the original numbers, I can still calculate the range. I have the maximum, which is 18, minus the minimum, which is 3, which is equal to 15. I can calculate the IQR, which is Q3 minus Q1. Well, this line represents Q3, oops, forgot to put my Q, which is 15, minus Q1, which is this line, which is 4. So my IQR is 11. So once again, even though we don't have the original numbers, we can still calculate a lot of information just from having the box plot. So now that you've seen how to create a box plot, let's talk about the advantages and the disadvantages of graphing our data using a box plot. Some of the advantages are they're great for very, very large data sets. So if I had a list of numbers where there was 100 numbers in the list, we may not want to look at all 100 numbers. We just might want a quick picture that summarizes all of that data. Well, a box plot can do that. The second thing is it's very easy to calculate or determine outliers from a box plot. And the last one is it also determines or shows the skewness of a distribution. And we'll talk about skewness a little later in a video. But just know for now that it's great for very, very large data sets and it's easy to determine outliers. Some disadvantages would be that you lose the original data. So if I had a list of 100 numbers and I created the box plot, I no longer know what those 100 numbers were. So if I gave my box plot to someone else, they wouldn't have the original values. They would only know the 5-number summary for that data set. Another disadvantage is you can only calculate a few statistics from a box plot. For example, you can calculate the range because you still have the maximum and the minimum displayed in your graph. You can also calculate the IQR because it easily shows the Q3 and Q1. And of course, you also know your median, which is Q2. But other than that, there aren't many other statistics you can calculate from a box plot. So, depending on your data or what you're trying to show will determine if you should use a box plot. Well, that's all for this video. I really wanted to focus on creating a box plot and the 5-number summary. Make sure that you can determine the 5-number summary if you're given a box plot. Before I go, of course, I want to give you a motivational quote or a little bit of inspiration, and the quote for today is, "The only way to learn mathematics is to do mathematics." So if my quote resonated with you, if you learned something from my video, then go ahead and give it a thumbs up. If you have any comments, questions, or suggestions that'll make my videos easier to understand, more engaging, then leave me a comment below or just tell me in class. And until next time,